Now, a queue is not language specific, and there's actually a couple different ways that we can create a queue depending upon what needs you have, and in some cases it may make it a little bit easier in one language or another. In fact, some languages already come with a queue data type that you can use, whether it's built in or an external library that you can import. However, I want to show you how to build a queue. In this case, I'm going to use Java, and we're going to create it using something similar to a linked list. I already have a class called element, which is going to hold a value and a link to our next element. This is important because a queue, remember, is a first in, first out type of data structure. I have constructors, I have a get value, and a get and set next methods already created for me. So let's look at what we're going to need in order to have for our queue. Well, for our queue, we need to know two of these elements, the first one and the last one. We need to know the first one because it's going to be the first one that we're going to remove. And we need the last one because new items get put on the end of our list. So I'm going to create a private element. I'm going to specify first and private element last. You could call these top and end, front and back. The actual names really don't matter. I like to use first and last just because it makes good sense. Now we're going to create a basic constructor. And notice I'm just calling them and setting them to null. So that's a pretty easy thing to do. Now I could also overload this constructor to take in an initial element. We're not going to worry about that at this time. We're going to focus on the other part we're going to use. In that case, the three methods that are commonly found inside of a queue. So our first method is going to be Enqueue. And since we're working with integers, you notice I have an int value parameter that's going to be passed into this. Now, of course, this could be an object. It could be a type employee. It could be a student. It could be a rental car. It could be a product. It could be anything we need it to be. Just for this example, if we're keeping it simple, we're using a value. So the first thing we're going to do is we're going to need to create an element that we can then enqueue. Next, we're going to check to see, is our first property null? If it's null, that means our whole queue is null, and that's going to make adding this element really simple. So we're going to say if this.first is equal to null, and then I'll say, okay, this.first is equal to e, which is the element that we just created, and we're also going to want to set this.last to equal e. And we're done for that situation. Now, if our queue is not null, then I'm going to come in here and say else this.last dot, and I'm going to set my next element for my what's currently my last element. This is adding an extra element onto the end of our queue. And that's going to be our element E. Once that element has been put there, we now essentially have a new last element. And so I'm going to update this.last is going to equal E. And this makes our pointer point to our new last element in our queue chain. And that's all we have to do to enqueue. It's very simple, just a few simple lines of code. The next thing we want to do is to work on dequeue, or removing an item from our list. This also is very simple. what happens if our queue is empty? Well, we could probably throw an error message like an exception. We could return 0 if we wanted to. There's a lot of things we could potentially do. We're just going to keep it simple and return 0. That way we don't have to worry about creating and throwing exceptions and stuff like that in this particular case. So I'm going to create an initial value called return value. I'm going to set it equal to 0. And I'm going to return that. I'm going to say if this dot first is not null. So this is a case where I'm checking to make sure that our queue is not empty. Then what I'm going to do is I'm going to get the value of my first element. This gets the value of my very first element, the one that's going to be removed, because remember, first in, first out. We're going to get that value and we're going to return it. But before we return it, that value is no longer needed inside of our queue. So we need to remove it. The easiest way to do that is we're going to set this dot first equal to this dot first dot get next. And what this does is it says, well, who's the next person in our list? Well, that person or car or whatever that element is now the first pointer. And so we've essentially removed that reference object from our queue. Then when we return that value, we've returned the value and we've removed that object. So it's very, very easy for us to work with. Now, I do have one more check I need to do in here. This is pretty simple, and we don't look at one possibility, which is what happens if our queue only had a single element. So what I want to do is quickly check to see if this dot first is equal to null. So if this dot first is equal to null, that means we're not pointing at an element. That means that this dot last shouldn't have an element to point at either. So I'll say this dot null equals null. So that's just a little check to make sure that we don't run into a potential issue. Okay. Now, I mentioned that there's 3 typical methods that you'll see inside of a queue. We've got 2 of them done. You see it's very simple, very easy to work with. So let's look at that third. And that third is going to be a check top. Sometimes people call it view top. Sometimes it's just called top. And what this is it's checking to see what's our top value. Now, you might say, well, wow, that seems a lot like the dequeue. How is it different? Well, in this case, we're just checking the value. We're not going to remove the item. So for simplicity's sake, we can come in here, and I'm going to just copy and paste this. But everything dealing with setting this dot first to this dot first equals next, I'm going to get rid of that. So it's a lot simpler. And now you can kind of see our code. Now, you might say, well, can we clean this up? Is there anything to make this a little bit easier? You bet. Because I have this repeated code in here already. So I could put that maybe into my dequeue operation. That way I don't have to repeat it. I also see that I have several cases where I'm checking to see if first is not equal to null. And so maybe I want to create a method that would be like a isEmpty method. And that way I can check to see if my queue is empty instead of having to say this dot first not equals null. This makes my code a little bit cleaner and easier to work with and helps me cement that process of dry. Don't repeat yourself. Anytime that I can do something to remove extra workload from me and extra thought processing, it's a good advantage to me. So there's definitely some things I could do there. I could also add a counter if I wanted to. And maybe that's how I use the isEmpty, is I check the counter. And so every time I enqueue, I add an item. Every time I dequeue, I remove one from that counter. And if I use a counter, then every time I enqueue, I can simply increment that counter. And every time I dequeue, I decrement that counter. That becomes an easy way of handling it. So there's a lot of different things that we could do based upon our choices here. Now, I have a queue app. And I'm just going to add some random values into this, and then we'll just slowly start to dequeue them so you can see what process we're going to use. So I'm going to say queue.enqueue 5. Here I'm going to dequeue an item. And if I go in here and run this, you'll see that the very first element that I put in is the first one that's removed. Come in here and add some more enqueuing and dequeuing. Sometimes I'm doing them in groups. Sometimes I'm going back and forth. If you run this, you'll notice that no matter how it runs, it's always the first elements that are enqueued are the first to be dequeued. And when we end, we actually still have some items in the queue. And that can actually happen in real life. Sometimes the system shuts down unexpectedly. Now, depending upon how we actually do our queue and enqueue, maybe we store these into a database, maybe we store these into a file as part of the exit procedure, and we can maybe bring them back up. Really depends upon your situation. But you can see how easy it is to create a queue system using a linked list. The huge advantage of this is that because you're not fixed, you can grow it to a near infinite size. You're only limited by your system resources. So there's a lot of advantages to doing it this way. And you can see it's relatively short. In Java, we're talking about only approximately 40 lines of code total. Now, can you add some features to this? Of course, and we'll show you some of those later on. But just for something simple, we want to show you this.